let's go into the module 1. So in the module 1, we will talk about Netflow Overview, and then we'll talk about in detail the flow collector, their function, and the flow cache. And then we finish off this particular module talking about a technology called NBA, Network-Based Application Recognition, which is another Cisco proprietary technology, which we'll be using nowadays to detect or classify the network traffic. So in the first module or first lessons, let's look at traffic monitoring overview and what's the basically all about Netflow. So if you look at a traffic monitoring, like just to understand the concept behind traffic monitoring, let's talk about like a traditional PSTN billing or mobile service provider billing. Early days of the service provider, they basically charge per call volume, amount of time you basically use in their network. To identify that, they need to have a keep of a record of your call flow. So this is a pretty much like one of my mobile bill, my phone bill. As you can see, they always have a sort of like a starting time of a particular call, and then basically they categorizing whether this local call or national call or international call. Based on that, they will be charging different rate. So how you determining whether this is a local call or international call? Based on the destination phone number, like if it is including a country code, it's a different country code, like an international call. So same like this kind of billing. So if you want to understand whatever your network traffic volumes, so you have to keep the same kind of detail, so if you look at it like a comparison of a similar kind of report in the IP traffic point of view, you need to keep a source IP address, destination IP address, and then if you want to differentiate which type of traffic is that, you can use the port number, application ID to differentiating a different type of traffic. And then again, in the IP traffic flow point of view as well, you have to differentiate different traffic flow. That means from one IP address to one other destination IP address using the same port number could be one particular traffic flow. So that way, here also similar kind of concept we'll be using, but just point to remember is, so you collecting the information you want, not every detail of IP header you are collecting. You want to identify the important information. So sometimes this we are called key field. So when we talk about Netflow, we'll understand those in detail. So what is the purpose of collecting traffic flow like that? What's the advantage? So that's the one thing to, there are many use cases of traffic monitoring. But if you look at, some basic example, so if you want to measure the performance of your network, then you want to monitor the traffic, like what kind of traffic going on your network, whether it is hitting your WAN links capacity, what does the traffic trend look like. So these are called network performance monitoring. So normally any given network, if you want to measure the network performance, you need to know what's going on in your network. In that way, NPM, what we call network performance monitoring, is one key aspect of traffic flow monitoring. So most of the time, people can use Netflow, or otherwise, if you have a wire level monitoring tool, you can do the same thing as well. But Netflow is a very common use case to measure the network performance monitoring. So whenever you have the idea of the traffic flow in your network, then you can plan for sometimes capacity planning in the service provider environment. Where the traffic demand is high, then you can proactively upgrade those links to meet the capacity needs. So like that, you can have a planning exercise or planning work. This Netflow monitoring or traffic monitoring will be definitely helpful. Much more than that, in today's context, actually security will become one of the key requirement. So if you want to defend your network, you need to know what's going on. So if you don't know, then you cannot really protect your network of those threats coming through that kind of path of your network or part of your network. So in that way, so sometime they can use sort of malicious, intention. They can use a different protocol, like for example DNS. So if you want to exfiltrate the data, they can pretending like a UDP port 53. So in that way, typically it is DNS. So now, unless you have a sort of application level signature detections, normally firewall level port 53 UDP may be open. So then, so in that way, if you really want to get the understanding threats, landscapes, and what kind of exposures going on your network, you have to monitor your network for application traffic, what kind of traffic is going on. So that way, for example, if you have a camera, IPTV camera, normally that camera should not communicating with international destinations. It should send the traffic to the IP recording server. But sometime if that particular camera had some vulnerability and somebody can compromise, and then they can using that camera, they can get into your company network devices and then try to exfiltrate those data through that particular device. So then out of sudden, if you see a camera communicating with multiple international destinations, so that is a way of you identifying that's an anomaly. In that way, how you can detect those anomaly, you have to have a baselining. In that way, to have understanding of your existing network traffic flow will help you to identify when the device starting misbehaving. So this is very, very important. Security play a critical role, and then network monitoring point of view, it is really important to know your network, monitor your network. In that way, Netflow perspective, if you have a tool monitoring your network traffic, that will help you to identify those kind of security vulnerabilities. So now let's look at a typical kind of network, what is this traffic flow we're talking about? If you look at example, in this particular case, I have shown arrow basically from outside to inside. Let's say example, one of the machine laptop here communicating with a web server. So now this traffic is coming from the web server to that particular client device. So now whenever that traffic goes through this particular router, so they will have a particular source address and destination IP address. Source will be the web server IP address, destination will be the client laptop IP address. In that way, source port and destination port, if it's a web traffic, most likely source port will be 80 or 443 if it's a HTTP or HTTPS. Destination port will be a random number because client will originating a session to a web server using destination as port number 80 or 443. So those port number will be using by the server to respond in the traffic. So protocol can be TCP, and then sometime depending on the QoS category as well. This can be a best effort traffic, or this can be sometime if it's a voice client, it can be expedited forwarding traffic. So your class of service may have a QoS priority value, different value. So in the sort of flow monitoring perspective, we define as a traffic flow as a unidirectional traffic stream, which will have this particular field value remain same. So if any of this value changing, so that will be a different traffic flow. For example, same web server accessed by another machine in the LAN network, that will have a different destination IP address, so it will be a different traffic flow. In that way, there are two traffic flow going from the same server to two different destinations. So like that, traffic flow, remember, it's a unidirectional traffic flow, which will have these particular field value, same value. So now as a sort of this particular flow goes through this particular router, so that particular router can keep a record of those important information you want to measure. In that way, source IP, destination IP, source port, destination port, and layer 4 protocol with the TCP UDP or the type of service value, and then even the input interface. So you can keep record of that. So those important information we call normally key field. So this key field can be sometime defined depending on the technology of flow monitoring. You can define what is the critical information for you versus having a fixed or static kind of field value. So in the early days of NetFlow monitoring, we had a fixed kind of flow field we monitoring. We didn't have the flexibility of adding field that you want to monitor. But with the sort of latest development of the NetFlow, they let as a customer we can defining what are these fields we want to monitor, and then there are two type of field we call key field and non-key field. These key field, those 7 field, source, destination, source port, destination port, and layer 3 type of service and input interface, these 7 field we normally known as a key field. Most of the NetFlow tool, they will basically monitoring their 7 sort of information. Other than that, for example, non-key field can be starting time, ending time of a flow, like how many byte, how many packet. So all these are what we call non-key field, where you can collect those particular parameters. So this is what happened, like when you're having a flow monitoring tool, so you normally collecting those field, either key field or non-key field. Sometimes we call metadata, like this is not the entire packet header detail, but important information for you to measure either bill or volume based billing or to detect something in your security perspective. This is the information you are collecting. So that way, so remember the traffic flow, how we're defining a traffic flow. So now in the Cisco NetFlow, it's technology that's important to remember. This NetFlow is a technology developed by Cisco. In that way, it's a Cisco proprietary, even though the non-Cisco device is supporting this technology developed by Cisco. So in a NetFlow kind of architecture, so we understand if a traffic going through a device, network device, if it is supporting NetFlow, that means this device can keep record of those details which we talked about, metadata or key field or non-key field. So normally to monitor your network, we don't want to log into all these particular devices and look at the traffic flow. So what we really want is a centralized sort of flow collector, and then we can log into the flow collector, and then we can get an overall idea of your network. In that way, NetFlow monitoring kind of solution architecture point of view, you will have something called flow exporter. So this device called flow exporter, and you will have a central collector where it will collecting those NetFlow data. So in that way, this will not no need to keeping the flow record forever. So it can basically simply export and forget about it. Like that way, for a period of time, it can keep it in a memory, what we call flow cache. But then flow cache can be exported, to a flow collector. So flow collector, when you're getting the flow collector, sometime depending on the number of devices in your network, sometimes same flow can go through multiple devices. In that way, whenever that data will be exported to the same collector can deduplicating. Sometime it will be processing those flow records and showing you nice sort of visualizations, analytics that you can easily consume. So in that way, flow collector has a distinct role, distinct functionality. So sometime you remember we talk about traffic flow. It's a unidirectional traffic. Sometime if you want to understand bidirectional conversation, those kind of sometime we call flow stitching, that can be done by the flow collector. So in that way, you can consume those flow data easily. So now when Cisco developed this technology, again, before just to move that, just remember NetFlow is not a full data packet captures. In that way, it is not a wire data. So it is up to layer 4. Key important information you will basically measure or basically recorded and using for your analysis purposes. So now the NetFlow version wise, original version we call NetFlow version 1. It has a basic capability, they didn't have something called sequence numbers. In that way, if you are missing a flows, there's no way to differentiating whether there's a flows has been missed, but this is one thing, like initial version, there are no sequence numbering were there. And also BGP service provider environment, like internet traffic routed using AS numbers, autonomous system numbers, but that information is not able to capture using NetFlow version 1. So that's a sort of limitation in the Flow version 1. So then there were certain Flow versions, like Cisco never released, but version 2, 3, 4, there are no publicly released those particular NetFlow version. So the main version you will see, even if it's a legacy device today, you should see they're sending NetFlow version 5. So NetFlow version 5 is a most common version. They added that sequence numbering and BGPAS information. The important thing to remember is NetFlow version 5 is like a fixed template where you don't have the flexibility of defining what information you want to monitor. So in that way, it's a static kind of fixed version of the flow template, and every device exporting those parameters when the traffic flow going through that particular device, it will basically exporting those details. So again, version 6 is never released, and version 7, Cisco introduced that too specifically for Catalyst 5000 series switches. Then version 8, they added some aggregation schemes. Version 9 is the second sort of most common NetFlow format you will see. In that way, nowadays, most of the devices supporting NetFlow format version 9. What is the difference between version 9 and version 5? We introduced this flexible NetFlow. Before we exporting the flow records, you can define the flow template, what field you are exporting. In that way, you have the flexibility to define a custom template and export those data. That's what the version 9 introduced. Other than that, version 9 introduces support of multicast, IPv6, even the MPLS. Those technologies supported exporting data perspective. In that way, version 9 is the one you should use in today's network. So now, because this is Cisco introduced this NetFlow, many other non-Cisco devices, like sometime they didn't really follow very well. So then IETF, they develop a open standard, what we call IPFix, like IP flow information export. So this is, the latest, the up-to-date standard is updated as of September 2013. This is based on NetFlow version 9. In that way, they use NetFlow version 9 as the base and develop this open standard. So then all the other vendors can basically follow IPFix standard, because if they're not basically following the Cisco proprietary NetFlow version 9. So sometimes people referred as a NetFlow version 10, but again, it is not technically NetFlow version 10. Why? Because NetFlow is a Cisco thing, but IPFix is a IETF standard, open standard. So sometime before having this particular IPFix as well, different vendors had their own version of flow monitoring. In that way, there's another method called sample flow, S-flow. The S-flow, the idea is actually not exporting every flow, every data flow we are not exporting. We are only sample and export. The idea is, in this particular scenario, flow collector is know what is the sampling kind of rate. That means every 101 packet of a 128 packet we exporting, then collector no scaling factor is 128. So if you're saying for flow collector got 100 byte, flow collector no, it need to be multiplied by 128 to get some sort of traffic volume. That may be basically 12,800 sort of a byte in that particular case. So certain vendors like Foundry, Extreme, HP, they started supporting the sample flow. And another type of flow technology called JFlow. This is introduced by Juniper Networks because Cisco introduced NetFlow and Juniper introduced their own flow method called JFlow. So like that, you may encounter these kind of different flow monitoring technologies, but in this particular digital course, our primary focusing about NetFlow, because NetFlow introduced by Cisco. Most of the devices we use in this particular digital course is Cisco devices. I'm again not going too much detail to the configuration side of all this Cisco specific thing, because it's not the intention of this particular digital course, but I will cover some basic NetFlow configuration on a Cisco router, and then we're focusing about wireless NetFlow, focusing about 9800 and ROS particular controller. So now, before going to the next sort of lesson in this module, keep a very clear idea. So NetFlow is pretty much can measure data or measure parameters up to layer 4. That means source port, destination port. So those are the sort of detail where you can get that information in the transport layer. So that way, layer 1 to layer 4, pretty much like IP address layer 3 and 4 mainly. So you can get some information up to layer 3 and layer 4 using NetFlow. But if you have technologies like application layer information gathering, like one example is Cisco NBA, network-based application recognition, where you can go up to layer 7. So whenever you go up to layer 7, then you can measure layer 7 specific detail. In that way, you can granularly differentiating the different application, even though they use the same UDP port number, for example 53, which we talked about, DNS. But if you have an NBAR, they can differentiate this is not DNS traffic, this is something else. So like that, you have a much more granular visibility whenever you have a network-based application recognition. So that way, this example of if you do something like that, then you can, you can application level, you can differentiate the traffic whenever you're having a NBAR. In that way, remember the difference between layer 7 monitoring versus layer 4. So NetFlow falls into like a layer 4 kind of technology. You cannot get any application level detail.